Thank you, Madam Moderator, and I'd like to thank Sev and all of you for the opportunity to share some perspectives today around the journey that many of our clients are going through in terms of digital transformation in the world of Industry 4. I am a director in our UK consulting practice, and the UK's an Industry 4 leader. And I'm going to orient some of the discussion today around some research that we conducted earlier this year around Industry 4 in collaboration with the Manufacturing Alliance for Productivity and Improvement in the United States. So first of all, just in terms of kind of where I'm going to focus some of the aspects of my presentation today, Industry 4 has got a very, very broad impact, not only on industries, but on society as a whole. The focus of what I'd like to describe and share with you over the next 15 to 20 minutes is focused on industry, and specifically on the act of production. But I think one of the things that we would recognise today is there is a connectedness across industry that is unparalleled compared to how it has been in history. The process, and a very linear process of supply chains, of designing products, sourcing the components for those products, making your products and shipping them to customers and providing the aftermarket, is collapsing into what we describe as a digital supply network, where the aspects of that supply network are far more connected. Additive manufacturing means the product design and make activity could in fact be done by your customers alone. The questions around the intellectual property around that are different, but that illustrates the collapsing of the digital supply and the linear supply chain into what we describe as a supply network. So I'm going to focus on the industrial impact and some of the journeys that our clients are going through, specifically in relation to the smart factory. So, first of all, what are the characteristics of what a smart factory? So Kai has touched on a number of these, so I won't dwell for too long. Firstly, and I think the underlying aspect around Industry 4 is this connectedness. So the connectedness of the real physical world with the logical or virtual world, the connectedness between people, data, and machines, and the connectedness between you as a manufacturer, your suppliers, and your customers as an integrated ecosystem, providing data and sharing data in order to be able to optimize the activity of production. But that connectedness is a means to an end. What that connectedness provides is a level of transparency which has never really been able to be pursued at the extent to which it can when you have that level of connectivity. Having that level of connectivity means the shop floor and the top floor can have a common view about performance, some of the underlying issues, and collaborate better around actually how those issues can be addressed. It also means that with traditional techniques around improvements and productivity improvements like lean, rather than one-off activities to run time and motion studies and gather data in a fairly ad hoc way, you have real data rather than approximations of how the business is working. And using that real data can provide far more accurate views about where there are underlying challenges and where are the opportunities to use either further traditional levers around productivity improvement or digital. The smart factory is far more agile than it's ever been. I mean, I've seen examples, and I know there's research and ongoing work by the likes of Boeing around how can they transform their manufacturing facilities to accommodate diverse products like their 787 Dreamliner and their UAVs. So by using things like digital work instructions and other ways of simulating and reconstructing how their production works, they're able to get far more efficiency from their production assets, and accommodate get far more efficiency from their production as well. We can be far more proactive. Given all this data, we mentioned predictive maintenance, but there are other well-established use cases now for how to use the data to be far more proactive about production. In the world of automotive, the just-in-sequence manufacturing techniques now used by many of the OEMs means that they're looking to get parts to the line at the point at which those products are being assembled, not from on-site inventory, but directly through their supply chains, directly into the plants. That has fantastic opportunities and realises great opportunities for those organisations by not having to hold that inventory, but introduce some risks. Because if there are logistics challenges or parts shortages with some of their suppliers, clearly that has a risk of interrupting the production operations. And in the world of some automotive OEMs, where a stoppage on the line can cost anywhere of £20,000 or more per minute, actually making sure that there is the throughput to be able to deal and handle that is essential. And proactivity means by having real-time data from suppliers and being able to assess the risk within the inbound supply chain means that we can be far more proactive. Finally, the smart factory is optimized. By having this real-time data, we can be far more deliberate about how we optimize the active production. Some of the work that we've done with one of our partners, McLaren Applied Technologies, has been taking the world of Formula One simulation into the factory. So we can now run millions of scenarios through simulation to look at how to optimize the production. For example, optimizing changeover times, the amount of inventory, customer demand, and also volatility on the inbound supply chain as well. So the 5 key characteristics around what we would describe as the smart factory. So a little bit onto the study. So we surveyed around 600 executives, we held focus groups, we held structured interviews, and specifically to the US market, we also looked at the impact of digitization on the US economy as a whole, but I won't labour too much on that US specific to this. I will cover a few specifics as I go through the remainder of this material, but just a few highlights. So we were able to assign our respondents into one of 3 categories in terms of the archetype of how they are adopting Industry 4 within the smart factory environment. First of all are the trailblazers. You'll see here that on average, about 30% of factory-related spend, according to our respondents, has been assigned around digital and the smart factory. For trailblazers, that's nearly 2/3 of the spend. 65% of the spend is being allocated, and that was about 20% of the cohort that were actively involved in the smart factory. The second cohort is the explorers. A bit more mainstream, just over 50% of the respondents who are active around smart factories we would characterize as explorers. They are venturing into more than just ad hoc use cases within the factory's environment and across their manufacturing plants. They have a structured program of work, and they are also looking more broad than individual factories, but also into the broader ecosystem as well. And I should point out that trailblazers, one of the key characteristics of them is they have fully digitized one or more factories within their production footprint, and are now looking at far more about the broader ecosystem, about bringing engineering and supply chain and others into that connected ecosystem around the factory. Finally, around 25%, 27% of the respondents were the followers. They are more cautious. They're waiting to see whether the technology is proven. But I think one stark highlight, and one thing that highlights, I think, the opportunity and the slight paradox around Industry 4, is that actually 50% of the respondents overall said that they weren't actively looking at the smart factory. They're looking at it for the future, and as you'll see from some of the highlights on the page here, they are looking to actually put further investment in, but it's only just around 50% who are actively working in the space now. And for a fairly mature market like the US, I found that quite surprising myself as well. So it is clear that there is a lot going on, and there is a very diverse footprint in terms of the maturity of organizations looking at smart factories, and a cohort who are actually some way behind, and I'm going to come back to some of the barriers that they see around adopting smart factory and digital within production. As we touched on already, I think on the right-hand side here, some of the challenges that are being solved are traditional challenges being solved in different ways. So we describe these typical values of value drivers of manufacturing. These won't be uncommon in many ways. So improving the efficiency of assets means that we can actually already drive more capacity. If we are resource constrained and capacity constrained in our production, that may be a hindrance to revenue generation. So there's a key lever there. Improving quality. Improving quality means I can reduce the amount of raw material that I need in the first place. It means that I can avoid the waste of physical product that is thrown out as scrap. And it also means that I can just get higher yield times and also the ability to reduce lead times without the extensive rework involved as well. Those can transform into different forms of cost. However, I think one of the important messages from the survey we conducted was the balance between the CFO and the executive view of levers that can be applied, and in the traditional sense that Kyle alluded to as well, but with some slightly softer levers around improving safety for the workforce And I think actually as part of the buy-in that you need to secure around Industry 4 is actually moving from the top floor to the shop floor and making the lives of your operatives easier on the shop floor. And I think that is also a key observation around some of the benefits around Industry 4, and some of the kind of the change and the cultural aspects is your shop floor operatives may not have the highest value around the cost reduction and so on, but making their job easier, I think, is a key component of the messaging and what you can support your workforce in adopting as well. I should point out, while our respondents reported double-digit improvements across these areas of production output, improved utilisation and improved labour productivity, the trailblazers actually report around twice that, so around 20% improvements across those different levers as well. So, use cases abound. One search on Google will throw up hundreds, if not thousands, of individual use cases, examples, and so on. But there were 6 use cases that really struck us from the respondents for this survey. I'll talk through these at a high level and maybe just talk to 1 or 2 of them in terms of some real-life examples to bring to life a little bit. So quality sensing and detecting can be as sophisticated as machine learning-based models that understand the configuration of machines, the performance of an operator, the ambient temperature around production, and so on, and actually have machine learning models that can then identify and predict quality-related issues. So in some particularly highly regulated industries where quality is of that level of nature, the use of that kind of technique to sense those quality issues can, as I talked about, reduce the levels of quality issues that are related as well. The second, factory asset intelligence, probably more familiar to some, so around predictive maintenance of machines, but not just about whether machines fail or not, about there are cases where machines can go out of calibration over a period of time, and that can be a very slow and steady process, not one where there is an immediate stop, but actually the quality of the materials and the products coming out from the machines actually degrades over time. So having that visibility around the machines and that asset intelligence helps to drive improved uptime and quality as well. We touched a little bit around plant consumption and energy management, the use cases around automatically switching off machines or areas of a plant according to kind of demand and activity within the facility. A command center, a little bit like I described in the automotive world, has that end-to-end real-time visibility of what's happening in the factory, the ability to simulate what's actually happening in the facility as well. Real-time asset tracking, I think, is an interesting one. It comes down to this concept of real versus approximations of what is happening in the factory. So, by way of example, we did some work with an industrial machine manufacturer. They had a very controlled and disciplined process up to the point of the end of their main production line. But then there was a degree of uncertainty around specific configurations for individual customers, potentially a bit of rework and so on at the end of the process. And that was effectively in the dark. So there were instances where this client was struggling to move capacity around within the factory for that. By adding real-time and data and sensors to the physical products, we were able to actually help them to better manage about a slightly chaotic production process at the end of the line so they could get benefits. Those benefits included better scheduling of the outbound transportation because they could get greater certainty about when products are going to be ready, and actually reducing the amount of time that those products were in the final stages of configuration and reducing the inventory carrying costs as well. And finally, smart conveyance. I was only last week working with a diesel engine manufacturer, and they, again, for the safety reasons, and not necessarily just a cost thing, were using autonomous guided vehicles to move large engine blocks around their facility to avoid the need to have humans involved in what could be quite a hazardous process in terms of those heavy pieces of material as well. Okay, so 2 audience I just want to talk to briefly. So at the top floor, again, coming back to our 3 cohorts, the 3 archetypes of organisations adopting Industry 4 in the factory, all of them have a degree of consensus and collaboration between different functions within the business. What is marked in the results that we had was the extent to which that actually operates for trailblazers and explorers as compared to followers. So the followers, it was very clear there is less consensus and less engagement from the C-suite across the functions of IT, engineering, operations, finance, and others than in other case. A critical part of the success of these initiatives, given how pervasive they are, is to have a C-suite that is supportive and aligned with what it is that's trying to be achieved. Interesting, in the case of trailblazers, we often found that actually it was the CTO who was taking the lead, which probably is a reflection of the focus around innovation within the business and the use of technology as well. But other characteristics around trailblazers and explorers are they are organizing in such a way that they have central teams that are coordinating initiatives across the business. So not just random acts of digital, but actually coordinated efforts across their different facilities. They have very defined measurement plans for what benefits they are expecting to achieve and how they are going to achieve them and how they are progressing. And they also have coordinated centers of excellence around some of the skills that they're developing. So in the areas of AI, IoT, and others, they are concentrating some of those skills because it is difficult to acquire some of those skills and it's difficult to retain them in a way that is haphazard or disorganized as well. But as I say, that it's not just about the top floor, and those of us in the room have the good fortune to be able to attend events like today. There is an absolute need to firstly make sure that the technology that is being proposed and embedded engages with the business in a way that actually they will adopt it. So one of the techniques we've found is using persona-based approaches, approaches which are very familiar in the customer-facing digital world, and applying those in the context of plant operations and looking at these types of typical roles. So plant leaders, shift supervisors, the quality team. What is it their role will look like? How will their roles be affected? Which both helps to shape the digital technologies and how they're going to be used, but also means that they are more engaged in actually shaping how those technologies will use themselves, which helps with the culture and the change aspects as well. As I say, it does demand new talents and skills, and there are, I think, as I've mentioned, different ways of being able to acquire and retain those skills within moving to a smart factory as well. So, keys to success. Firstly, I've mentioned the business case. Be very clear on the outcomes you're trying to achieve. I have, on occasion, had clients asking the question about how they can move to a lights-off factory. I think the question is different, which is what problems and opportunities can you solve through digital, and how will you measure, and how do you then set out the roadmap to achieve them? There are many different approaches to how you can get these benefits. Agile teams working locally within plants is one thing. The adoption of COEs for some of these different areas of skills are another. There are different techniques to be applied along the way. Engaging leaders is early in the process, I think is invaluable, as I mentioned, particularly around the C-suites and others. And not all of those individuals have the same buy-in or the same interest and the opportunity to join events like today, so show them. Organisations like Siemens, ourselves and others have fantastic opportunities to expose people to the opportunities, demonstrations through working with industry and other clients, for example, that your consulting partners and others may be working with. Actually having your executives see some of those initiatives in actions and see some of the results is a critical factor to the buy-in. But remember, it's not just them. One of the very successful approaches I've used on some of the engagements I've led with the firm is to have immersion sessions with those in the shop floor. Those in the shop floor don't necessarily have the opportunity to see and understand what some of these digital technologies can provide. Providing them the opportunity to see, touch, feel what some of these digital technologies will enable and what the improvement it will give to their working life is a critical part of the journey. Just one example with a medical device manufacturer, we had hundreds of people from a manufacturing facility go through an immersion session, bit of a kind of a fair around digital technologies, and we used it as an opportunity to solicit ideas from them, from the front line, about how they saw some of these different digital technologies could improve the way that they work and the way that the business runs. Finally, the piece around ROI and so on. A stark other piece of information around the trailblazers is, on average, they're operating something like 50 to 70 POCs across their manufacturing footprint. Very diverse sets of use cases, but it is coordinated. It's coordinated so that actually there isn't repetition in the work that is done. It's coordinated in the sense that successes in areas are communicated elsewhere within the manufacturing footprint. And that means that actually they are quite quickly finding out what works, what doesn't work. And to the earlier comments, they are thinking big, but they are starting small as well. So just to conclude, so I mentioned there's about 49% of our respondents weren't actively now pursuing their smart factory activities, but they are planning to in future. So there's a few different things, a few different kind of considerations to why that isn't the case. Firstly is this lack of experience. So it is a challenging world. And I think underlying the 4 areas in here is that it can be a high-risk world. Unlike some of the ventures that we can go into in terms of digital, in terms of the customer experience, getting something wrong in the shop floor is, at worst, financially detrimental. Sorry, at best, financially detrimental. At worst, potentially hazardous to our workforce. So there is, I think, a challenge around understanding the risks around digital within the production environment and putting in the right measures to make sure that those risks are mitigated along the way. Difficulty in adapting, it is a change journey, both for the top floor and for the shop floor. Putting the compelling business case together, perceptions around what is the right ROI, what are the levers that are acceptable in terms of a business case is critical as well. But also, what is the overall strategy? Who is it who's going to be responsible for driving this initiative forward? Who's going to be sponsoring it? What is the governance to make sure that that strategy is going to be implemented as well? So I will conclude there. From what I've heard so far today, I'm pretty excited. I think you've got a fantastic opportunity for the Greek industry to seize the opportunity of Industry 4. So thank you again, and I'm very glad to be here as well. Thank you.